Hey guys and gals. Hey guys and gals. What is good? What is good? Thank you so much for hitting that play button. Turn it up! Let's go! Appreciate you doing that. I appreciate it so much. Thank you for being here. Yeah, let's go. All right, quickly. I'm gonna try, guys, quickly. For you parents that are homeschooling your childs, here to support you. Also support your decision in doing that. I fully understand. And yes. I am with you, and I am here to help, here to support you. Assuming possibly you probably have lots on your plate, I imagine. It's a lot, right? So, here to help. Hopefully, I can help alleviate some of the stress for you. To be clear, to let you know that I'm going to 100% focus on the mathematics. That's what we're teaching over here on the channel. So I'm also along the same lines, every teacher, every instructor, they should be teaching the subject and the subject alone. That's it, right? So, and yeah, that's the way it should be, 100%. Nothing more, nothing else. So, and then also students, you're welcome here as well. 100%. Definitely you are welcome here. Now, if you're looking for extra additional support online on YouTube, that's fine. That's fine that you're doing that. There's nothing wrong with it. There is a good chance that maybe your current teacher is not so good at teaching. There could be that, right? So whatever the reason is that you're here looking for additional help and support, I am here to help. Parents, students, letting you know if there is a specific area in mathematics you would like me to, do for you, like as in a series or whichever. I guess it depends on the topic. Let me know in comments below, and I'll do my best to, I'll put out some content for you, right? That's kind of what's happening over here right now. I know for a while I've been doing the Unity stuff, but eventually I get to the point where I don't know, I think to me this is more important, right? This is more important, and plus I love mathematics, and so here we are, right? Here we are. A little bit about myself. I am a college educated. I do have a couple of degrees actually. But that's my first one was when I was obviously younger, and then as I got older, I decided to take an IT kind of course too. But that's not really what I'm doing now. But anyways, at the time when I was in college, I was lucky and blessed to have instructors, teachers that actually were teaching the subject. And because of that, I excelled in the program and top of my class and all those sort of things, right? I'm just going to say, right, I'm going to be modest here. Like, I did well, I was successful, and it just clicked for me. So I just dove right in, I loved it, and I grinded lots of math. That'd be also including calculus. Maybe sometime at some point, maybe I'll do calculus. I don't know. But for now, just focusing on the high school program. Okay? All right. With that said, thank you for listening and understanding. Again, I'm going to focus on mathematics. Therefore, equals. I'm more qualified. More qualified than that other one. The other instructor. That's not teaching, right? Over here we're teaching. Let's go! Drop in the yays, some quick coffee, and let's do some mathematics. Oh yeah! Excuse me, guys. I like to take advantage of having some coffee at that moment. Get parched, get a little thirsty. Normally, I'm the kind of person sit and work. I'm one of those people that I don't need my handheld, right? I'm kind of one of them people that I can do it on my own. I don't need people helping me. I figure things out. I do things on my own. I use my own brain molecules, I guess, if you will. I don't need somebody to carry me or hold my hand. Okay, I'm not being mean or anything, but it was kind of like that when I was designing drafting as well. I'm a doer, a doer and a thinker. Okay, I don't need to call my cousin Bob and ask him how to do it. I figure it out. Okay. All right, so we're going to continue. We're, as promised, we're going to do this problem, okay? So let's begin sketching it out. So I don't know, maybe right here. I'm going to try my best to kind of draw it. I don't know how perfect it's going to be, but... Okay. Good enough, close enough. Okay, guys? Again, it all looks good from an airplane. So this is 24 meters. Flick that switch in the head, guys and gals. We're getting right to it, okay? Let's learn. 15 meters. Now these two circles here, really what they're trying to tell us is that they're the same angle. They're obviously obtuse angles, and they're opposite each other. So if you're working on a problem such as this, and then maybe the question is, or maybe your instructor asks you, or whatever the reason, they go, what is your explanation of why this angle is the same as that angle? Well, 1, 2, 3, I guess, reasons. One is they're obtuse angles. So I guess that's one reason. And they're opposite each other. And then 3, I don't know, the other thinking, my kind of logic is, we have this straight line here, right? Now, of course, I haven't drawn it perfectly straight. Can't exactly put a ruler on my monitor and draw this out for you guys. As much as I would love to be able to do that, I can't. And plus, you're not going to see me drawing on my monitor now, are ya? This line here is perfectly straight line, right? Let's just imagine that. It doesn't change angle, it doesn't change rotation, it's consistent. It's a consistent straight through line from this point all the way to this point, right? So therefore, same thing with this line as well, right? Same thing. Same concept. These angles aren't changing, the line isn't changing, the rotation isn't changing. It's consistent throughout from point to point. Therefore equals the angle is going to remain consistent, unchanged. Same thing with this angle. So, and then these opposite angles are also going to be the same. So this says X and X. So what they're saying here is they've put in X and they've put in X. What they're telling you is that these angles are the same. And then check mark and check mark. Okay? Same thing. Same concept. They're telling you that this angle is the same as this angle. And this is true. Okay? So imagine this is a pivot point, right? And let's say we take this triangle here and we rotate it 180 degrees. If you do that, if you imagine it in your mind and you rotate this bottom triangle, this check mark is going to line up with this check mark. Well, not perfectly, but it will be in this area. Same thing with this X. It's going to end up here. Right? I mean, that's a lot to explain in a paragraph, but that's kind of the general consensus, I guess, if that's the right word. Okay, general idea, general concept. Okay, so, and then let's get our last value. That's W, which is what we're going to solve for, and then over here is 20. Okay, W and 20. So in this case, we could use the same concept. If you've been following this series, I hope you have been. I recommend you start the series from the beginning, guys. I offer a lot of tips and tricks and advice throughout each kind of video. Each video is kind of unique, and it's going to have different things going on, different explanations. I try to be thorough and I try to explain things. Maybe if some of you guys are watching and you're thinking, oh, I already know this, or whatever you're thinking, like, I don't know, you just realize that I'm doing this for those that, I'm assuming that anybody that's watching is maybe having difficulties, or it's a challenge for them, or they're new to it, right? So if you are already familiar with it, that's great. But try to understand that there may be others that are watching that, need the extra a little bit of support, right? So that's what I'm doing. Okay, so let's carry on. Let's solve this. So we're going to use ratio proportion. Okay. Good enough. All right, and basically I'm going to use, this is what I like to be. I like to be consistent with the way I work problems. And I'm going to use the y over x kind of concept. I know it's not really y over x in this case, but technically speaking, this could be x and w could be x. Okay, I look at x as horizontal, and then I look at y as the vertical. Okay, that's kind of the way I look at it. So I'm going to make, as long as you're consistent, it doesn't really matter how you do it, but the main thing is be consistent. Okay, so I'm going to, let's call this triangle 1, and this one triangle 2. Okay. So basically, I'm not sure what I was saying there, but let's carry on. Let's make triangle 1 equal triangle 2. All right, that's kind of the idea. So I'm going to basically have y over x equals y over x. This is what I'm just using these as kind of for substitution from here. Okay? And plus to give you kind of an idea what's up. So, but in our case, w is x, right? W equals x, right? Because I'm going to call that my horizontal, and I'm going to call this my horizontal. So let's work with triangle 1 first. Okay? So triangle 1, whoops. So y is going to be 20. Okay, looking at the problem. Yes. 2015 and 24. 2015, 24. Okay, just double checking I didn't mess up my numbers. Okay, y is 20. And my x is going to be w. Okay, so we're making t1 equal t2. So now let's look at t2. My y, I'm just going to pretend it's y, even though really it's not, but let's just pretend. Okay, x works for this. So y is going to be 15, and x is 24. This is the consistency part that I'm talking about, okay? Now we've got everything set up, okay? We got our ratio proportion set up. That's key, getting it set up properly. Okay, at this point, now it's just a matter of cross multiplying. That's what I call it. That's the way I look at it. Okay, so W times 15. I always want my variable on the left side. So I'm going to go 15 times W equals, and then we're multiplying this now. 20 times 24. That's my multiply right there, okay? So now we got everything kind of in a horizontal fashion. Linear. Linear means straight line. Okay? Alright, give me a sec. Alright, let's continue. So at this point, a lot of instructors will teach just divide both sides by 15. That's fine. It all works the same. Essentially, you'd be canceling this. That's fine. It's still fairly simple, but you're doing some extra writing, I guess. Extra writing I don't really like, because what it does is the more you write, the more clutter it becomes, the more kind of disarrayed it becomes in your mind when you're looking at it visually. So to simplify things, we just take our 15 and put it underneath as a denominator. That's all I do, is I go whoop, boop, done. Okay, so let's write it out. W equals, I'm going to show all the work so you can see each step. Right? I don't want to skip any steps. I don't want you guys, going, what did he do there? Oh, the humanity. I don't want that, right? See? All I did was just take the 15 and put it underneath as a denominator. That's simple. Okay? Now we could actually factor here. Just to kind of, I'm going to go up to here. Okay? So I'm just carrying my work up to here. That's all I'm doing right now, okay? So I know 5 goes into 20, and I know 5 goes into 15, right? So let me show you the work, right? 5 times 4 here, and 5 times 3 here. This is factoring and reducing, okay, guys? I recommend it right ahead of time. If you do your factoring reducing now, it's going to make factoring, because you have to still do it anyways regardless. Okay, so, and plus this is going to make the multiplying simpler when you actually get to your final answer. So let's carry on. So I'm going to break 20 apart into 5 and 4. Essentially that's all we're doing, guys. Factoring and reducing, okay? The 24 remains unchanged. I'm only focusing on the 20 and the 15. Okay, this is because we're only working with 2 values, a single numerator one and a single denominator. You can't do it for all of them. You can only do it for one. All right, if you're wondering. So 24 is just kind of hanging out. It's unchanged. We haven't done anything to 24. So we just broke 20 apart. Now we're going to break 15 apart. It all means the same thing, guys and gals. And then, of course, there's nothing else. Right? Technically, I wrote it that way so you can see that this is the reason we factor like this. We need that common number. 5 goes into 15 and 5 goes into 20. Right? We have to pick one. Wait, obviously 5 doesn't go into 24, right? But 3 does, but it's not what I want to use. I want to take as much meat off the bone, and the biggest number I could use, the better. That's why I chose 5. Okay, obviously 5 divided by 5 equals 1. That's what we want.
Okay, that's our factor. The number we're pulling out. We're pulling off the most meat off the bone. I know it's kind of a weird analogy, but it works. Okay, so if I continue my work here, we're left with 4 times 24 all over 3. Okay, but we're still not done. We could actually factor some more here. I could reduce, like, there are going to be situations where you don't have it reduced all the way, right? You might have to do an extra reduction. Okay, so, but I'm going to factor some more without even using a calculator. We're just going to do the whole work without even touching the calculator, right? Because we're 120 IQ club here, guys. Okay, you should be able to mental math this. This is what's going to make you better, right, than your peers. Okay, you're going to excel. So I could factor 3 out of 24 because I know 3 goes into 12, and 24 is double 12, right? So what times 3, obviously if you know your times table, what times 3 gives us 24? Well, that's 3 times 8, right? So I could factor a little bit more. So I'm breaking, and obviously 3 is going to be 3 times 1, right? So there's our common number, 3 and 3. So we're going to do the same thing. This is good practice, guys. Get used to factoring, trust me. As you advance in higher levels of mathematics, you do a lot of factoring. Especially when you get into the higher math. Okay, I'm just telling you. This is easy factoring, all right? So 3 times 8. Oh, I forgot my 4. Okay, I don't want to forget the 4. So I'm going to just put the 4 over here. Make sure you don't forget that, okay? Because then that's how you'll get an incorrect answer, right? I'm working with the 3 and I'm working with the 24. Okay? These are going to cancel. This is essentially 3 times 1, right? So, look at that. Now we have a denominator of 1. That's perfect. That's perfect. That's exactly what we want. So now all we have left in our numerator, I know there's a little bit of stuff going on here, but these are canceled. Just imagine that they're not there. They do not exist. So we're left with 4 times 8. 4 times 4 is 16. So 4 times 8 is 32. Boom. 32 should be our answer for this. Equals 32. And that's going to be meters. Works out nicely too. So, does that make logical sense? 20. Yes, it does make logical sense. So if you think of it, this leg here is 20. This leg here is 15. 20 is greater than 15, therefore equals W should be greater than 24, which is true. Okay, I'm just thinking of it logically, right? This triangle here is larger. That's why it's 32. And my answer, my reasoning is, it's because 20 is greater than 15. That's why W is 32, which is greater than 24. Okay? That's a little check. You can call it a check, right? Now, do I have these answers in front of me? I don't know. They're somewhere, but let's see. Here it is, number 15. Yes, 32. That's big yays. Big yays. Now, I know it takes a little bit for me to go through the problems, guys. Okay, just take note, right? You know, for me, like I'm obviously explaining it and all the steps and showing the work and all that stuff, right? If you're doing this kind of problem on an exam or whatever, you want to smash it out in a couple minutes. It depends on how much time you have. Okay? My analogy is if you have 30 questions on an exam and you only have 1 hour, then that means you only have 2 minutes per problem. It just depends how much time you have and how many questions you have, right? Now, some questions you're going to do in like 5-10 seconds, right? Other questions might take 3 or 4 minutes. So it's kind of a balancing game too, right? Now, if you're stuck on one problem, I recommend you just put a question mark and then come back to it later, right? The key is, my main point is, this is my advice and tips for doing exams. Don't focus or spend too much time on one problem. That'll kill the rest of your exam. You're better off just forgetting that problem entirely and having that problem be wrong. Because if you spend all the time on that one problem, then all of a sudden you ran out of time. Let's say you had 15 questions left. Now they're all incomplete. What kind of percent mark are you gonna get, right? So you're better off just going, okay, I can't figure this one out. Go to the next one. Just come back to it at the end of the exam. All right, that's my kind of best tips. All right, so we're done with that. Let's carry on. Let's go here, okay. And we're gonna clean things up. Okay. All right, perfect. So let's quickly go over polygons, okay? Just quickly. Just as a refresher. Polygons. Okay, what are polygons? Polygons are closed figures. Keyword is closed. Formed by line segments called sides, right? Every shape has a side, right? Like a square. Technically speaking, I guess a square and a rectangle would be polygons, right? The sides meet but do not cross. Okay, that's another point. Okay, the sides meet but they do not cross. The point where two sides meet is called a vertex. So a corner, if you will. So we have 3 polygon shapes here. So here are some examples of, I'm going to do my best to kind of draw this shape. Okay, 5-sided polygon, right? Vertex, right? Trying to write that properly. Vertex. That is supposed to be an R. Decided to write it again. Kind of writing it at an angle here. So, okay, there. Vertex. We have sides, and it's closed, right? Here's another one. Okay, there we go. Another polygon, and then another random shape. It's not going to be perfect, but you get the idea. Okay? All right, guys? They're all closed and nothing intersects. That's key, right? So what are not? So these are polygons, check, okay, but these are not, okay. So there is a name for this shape, right? We basically have a rectangle with a, technically speaking, there is a half circle there, right? Okay, so anything with curved is not, okay? These are not polygons. Something like this. Not a polygon, right? We kind of did a word problem like this, right? And then also this. What, the Batman? Right? Open, right? Right? Remember, the key is they have to be closed to be a polygon. Okay? They have to be closed to be a polygon. And they can't cross. And no half circles. Okay? All right, let's continue. So here's a question. Is it a polygon or not? Okay, I'm going to try to draw this one. There's a lot of sides. I mean, to be honest, I'm just going to draw it like this. Okay, there we go. Okay. Check, yes. Is this one a polygon? Now there's a little radius there, okay? So it has a slight radius? No. Is this one? Whoops. Sometimes I get these little legs. No, right? Because they cross. And then try to draw this one. Ugh, jeez Louise, Sally on Sundays. Okay, good enough, close enough. Okay, this one? Yes. All right, there, that's it. Polygons in a nutshell. All right, similar shapes. Is each pair of shapes similar? Oh, this is a good one. Okay, so all right, we're leveling up a little bit, guys. We're leveling up a little bit in thinking here. I gotta make sure I give myself some room to work. Okay. So we've got this, we've got this, and this is 32 degrees. Okay, now we're working with angles, okay? You should know what this means, this symbol. And then we have another one.
58 degrees. Okay? Is each pair shaped similar? Okay, yes or no? How do you figure that out? Right? Okay? Recall. This symbol means 90 degrees. Always. Okay? Always. Always 90 degrees. Okay? With that symbol, the box symbol I'm talking about. If it has no box symbol, then it has to give you a value, okay, of some sort. All right, so going back, remember, so I don't really want to write it out. Maybe I have it here. Yeah, let's go back here. Right here. Complementary angles are two angles with a sum of 90 degrees. Okay, complementary. Remember that. I think of it, C is before S. 90 is less than 100. So 90 goes with C, 180 goes with S. That's how I remember it. Complementary, 90. Little tricks to help you remember stuff for exams. Okay, should always have some kind of little, like, create your own little tricks and ways of remembering stuff. Okay, guys, work that brain. You're all beautiful, intelligent people. You know this. You know this. Let me bring something up quickly. This is for you. Whoops, cancel. Figured I'd throw that in for you because you love it. You know you do. All right, let's carry on. So how do we figure this out, right? So we know this is 90. I know we could use the same concept. We could use, technically speaking, right? All triangles have supplementary angles, which is true. Supplementary angles are two or more angles, okay? In this case, we have a triangle, and every triangle, all interior angles, I do go over the concepts a lot, guys, but repetition. That's how you sink it in the old man brain, okay? So all interior angles add up to 180 degrees, essentially. And hopefully, I'm a little more awake today. I set up my formulas better for you guys. Hopefully that didn't confuse you too much that last couple of videos ago. But at least I rectified myself. I tried to clarify, and hopefully it helped. All right, so I'm going to ignore the 90 because really, if you think about it, if you go 180 minus 90, well, what are you left with? You're left with 90 degrees, right? So I could just ignore these, right? And all I need to do is just do these. We need to figure out this one, and we need to figure out this one. Well, it depends. Now, if we figure this one out and it equals this value, then they're going to be similar shapes, right? Looking at this right now, it's quite possible because I know 8 and 2 equals 10. So I'm thinking maybe, but we'll do the math, right? You probably already know, but that's okay. Let's do the work. So I'm going to go with 90, right? All I need to do is, I could do all the extra math, but really without over explaining it,
we don't need to subtract this extra 90 degrees. Just know that this is a right triangle, right? Both of them are right triangles. And instead of doing all the extra subtraction from subtracting from 180, we're really left with 90. So all I have to do is go 90 minus this. All I have to do is go 90 minus this will give me this. Okay? I hope you're following. So 90 take away 32. And what are we left with? So I guess we'll do the, I should have set it up here, but that's okay. Actually, I still can. Let's do that. So we're subtracting from 90 from 32. Okay? Triangle 1. Triangle 2. Okay, we're doing triangle 1. Okay? And subtracting. That's going to give us this angle. So, I need to get rid of that T1 up top there. Because we have to borrow. Okay, this is going to be, we're doing the work for T1 here. Okay. Borrowing. So we're going to borrow from the 9. The 9 becomes an 8. The 0 becomes 10. We have 10 take away 2 equals 8. And 8 take away 3 is 5 jumps, which is 5. Boom. So that's the answer for here. So looking at it, therefore, T1 does equal T2, right? Because 58 equals 58, right? We could do the math and solve this one, but we're going to know that we're going to get 32. We don't really have to do it twice, right? Because this angle is 58 degrees in triangle 1. Triangle 2, the same interior angle has a value of 58 degrees. Therefore, T1 equals T2. Boom, boom, boom. Similar triangles, guys. Okay. This one's a bit of a mess doing this one. So they're trying to make us work a little bit more here. So that's okay. We might still be able to use ratio proportion to figure it out. So we have two Tetris type shapes. Okay, and then we have one that's just a little bit smaller. Okay. Just imagine they're perfectly, whoops. Okay, perfect straight lines. They've given us a lot of values. The units are centimeters. I'm not going to write centimeters 30 times. I'm just going to write the value. 6 and 8 and 3 and 12. I don't know. I could call it L shape, or I could just call it S1 and S2. Okay, good enough. Shape 1, shape 2. This is 4. This is 6. They're giving us a lot of information, guys. 2 and 8. So the question is, are they similar triangles or similar shapes? I think, if we figure out using ratio proportion, I think if we, let's let's use these values here. Okay, if we just use those, ignore these, just ignore them. And I'm thinking if these work out to match, then they're going to be similar shapes. Let's find out. So let's make shape 1 equal shape 2, right? I'm just going to go with the y over x concept, right? So, which equals, so for shape 1, y over x is 6 over 12. Okay, you see that, right? Which technically speaking is equal to 1/2, right? If we reduce it. You know this, right? So imagine you just factored 6 out of both, right? That's what you're left with. Okay, let's do this other side. Same thing. Y over x for shape 2 equals 4 over 8. Which, same thing. We factor 4 out of this and factor 4 out of that. We're left with 1/2. Now, with that said, I'm thinking, because we used ratio proportion, well, not really, we didn't really actually, but we reduced and we got an answer of 1/2. We've got an answer of 1/2 here for S1, and we have the same answer for S2. Right? The ratio kind of works out. Because fractions really are ratios. Okay, guys? So now I could do the same thing here, I guess. We could do an extra confirmation. Just to check. So we got 1/2. I mean, technically speaking, the other sides might not be exactly the same. So let's do 8 over 3, 6 over 12. Okay? So y is 3, x is 8, so I get 3/8. Okay, it worked evenly with these sides, this side and this side. Let's see if it works evenly with this side and this side. So y over x equals, so y is 2 over 6. If we reduce it, we get 1/3. So they don't equal each other, right? So in this case, S1 is not equal to S2. When you cross out an equal sign like this, that means not equal to. Okay, so there we have it. I'm going to check the answer, see what they say. Maybe I have the answer. I don't know. To be or not to be? Yeah, it doesn't look like I do. Or do I? Oh, okay. B. No. Since the corresponding sides are not proportional. Yeah. See, we figured it out. We did the right work. We did the right work. Now, it doesn't matter if you had 8 over 3. Like, it depends on your ratio setup. We could have ended up with 8 over 3. We could have ended up with 3 over 1 here. Okay, it doesn't matter. It just depends. Like, I'm using the y over x. You could also go x over y, right? But obviously 8/3 is not equal to 3 over 1 either, so it remains true. Alright, there you go, guys. So it's not. It was a good thing that we checked, right? Instead of assuming the first time
just because you got 1/2 for one side doesn't mean it's going to work out the same for the other. Yeah. All right, what else do we do? How are we doing for time? Yeah, boy, time flies when you're having fun. Let's see, what is this? I just want to read this. Oh, okay. More ratio proportion, essentially. We'll see if we could do this quickly. So, I'm going to try to draw it. I don't know if I can. So, I'm just going to kind of do a rough drawing. It's kind of three-dimensional somewhat. Okay. So just imagine this is a countertop. I'm kind of drawing it three-dimensionally, kind of. Right? This would be the floor. Right? Sort of thing. And I'm just going to go like that. Okay? It's a crude drawing, but pretend this is a sink countertop. Okay? So this distance here, they give, and I drew it kind of too high there. I didn't give myself any room for the dimension, but it's 125 inches they give us. Okay? And then they give this distance here as 60 inches. Hopefully you can see that okay. So now I'm going to do a bird's eye view. So we have a scale diagram. And I'm just going to kind of go like this. It's the top view of it. I did kind of like a 3D kind of perspective here. Okay, it's kind of a 3D perspective. It's not perfect, but I'm just trying to, throw these problems out quickly for you guys, okay? If I spend, a half an hour drawing things perfectly, we're not going to get much learning done, right? So I'm just going to kind of crudely draw the sink here. Something to that effect. Okay, good enough. So they've given us this and this. And it's just kind of a sketch. Let's just say it's a sketch. This is 10. Okay? And they've given us a dimension here, but it's really not important. Okay? We don't need it. We're focused on this backside dimension and this long side dimension, which the way I've drawn it goes to here. Okay? That's good enough. And so this is unknown right here, X. X is unknown. Okay, again, it's the same thing. Be consistent. I'm just going to call this Y over X. I'm just going to use it as X anyways. It doesn't matter. So X is going to be X. So I'm just going to go like that. So we have our 3D sketch and we have our kind of top sketch. We want to figure out what this distance is. This, I guess you could physically measure. Maybe somebody's trying to draw this image to scale. They're using kind of a scale concept. And they want to know how long this line should be when they draw it, or something to that effect, right? So you could use ratio proportion. So let's do this side here. We have
So x is going to be our 60. Okay, so therefore 125 over 60 equals, so I'm going to say this cabinet equals this cabinet, or whatever. It's not a cabinet, countertop. Okay, y over x, our y is going to be 10, and x is unknown. Okay, make sure they match. 60 is x, y is 125, 10. Perfect. Okay, let's do the math. Cross multiply. As a matter of fact, I could do the smart thing and just cancel these zeros. Done. Right? You can do that. Trust me. But they have to be the exact same amount. If this was 100, I could still cancel a 0, but it can only be 1 0. It has to match. Okay, so cancel the 0, cancel the 0. So I'm left with 6 here and 1 here. I just saved some work. X times 125. So 125x. Hopefully you're following what I did. It's just a little trick. You can reduce. I essentially just reduced here, guys. Make the numbers smaller. You can do it on a calculator if you're not sure what I did. Go 10 divided by 60 and do 1 divided by 6. This should equal that. Okay? You'll get the same answer. All right? Trust. So 125 times x equals, well, essentially 6 times 1, which is 6. So isolate x. X is going to equal 6 over 125. Do we have any decimal values? No. So essentially we're going to end up with a decimal value. Can we reduce? Does 3 go into 125 nicely? Not thinking that it will. 125 would be 4, 5. 5 would obviously go into it, but not 6. I don't think 3 will. 3 doesn't go into that nicely either. So we're going to end up with 6 divided by 125. We're going to get a decimal value. Okay, x is going to equal 0.048. That's crazy. That is crazy. Do I have the answer for that, I wonder? I don't think I do. Or do I? I did something wrong. What did I do wrong? Canceling. No. I know what I did, guys. I know what I did, okay? And I super apologize. This works great if it's 10 divided by 60, okay? I just realized my error. Now, if this 60 was underneath the actual 10, like I'm showing here, I can do this. But it doesn't work when you're cross multiplying. You can't do that. So guys, please note, okay? So be aware of this. Be aware of this. Okay? Be aware. It only works, you can only cancel zeros if it's an actual fraction. if they're together. Okay, this is not with that. These are not together, right? We're separated by an equal sign. That's why. Okay, I can do that here, yes, but only if it's in fraction form, right? Okay, so try to remember that, guys. Don't take that advice on that. You can still do this. Like, let's say I had 100 divided by 6,000, right? I can still do that. Again, take note. It has to be in fraction form to do that. And I can cancel the same amount as zeros. So I'm left with 1 over 60. Okay? But, yeah, man, my bad on that. Okay? It was an oversight on my part. So, let's just do the work again. 125 x. Just wait till you get it into fraction form before you start doing that. 125 times x, and then we're going to get 60 multiplied by 10. And then so basically I'm taking the 125, I'm going to go underneath like we've been doing the whole time. This step is fine, guys. It's fine. So we're left with x equals 60 times 10. Well, that's 6 times 1 with 2 zeros, which is 600 divided by 125. Now I can actually reduce, because I know 5 goes into all of these, and 5 is kind of the largest number I could think of. 600 divided by 5 gives me 120. So I'm just going to actually pull 5 out of this. I get 120. I'm going to see how far I can reduce it. 5 goes into 125. 25 times, right? 5 and 25. And as a matter of fact, I think I could go more. 5, does 5 go into 120? I don't think so. Oh, it does actually. Look at that. I can reduce more. So as a matter of fact, but that's okay. I'm kind of running out of room here. Let me do this. Bring this way over here. X equals 600 over 125. We're just about done, guys. I apologize, taking a little longer. And then I'm going to reduce. Again, I'm going to end up reducing twice because I'm not sure. Let's say I'm not 100% sure what the most meat off the bone is, right? 600 divided by 5 is 120. And then 5 goes into 125, 25 times. Okay, so we're left with 120 over 25 because these cancel. And 5 goes into 120 actually, so we could actually pull another 5 out of that. So I could actually pull 25 out of both of them. So 120 divided by 5 is 24. And then 5 times 5 is 25, right? So we're essentially left with, that's it. That's the lowest we can reduce it to. Because 5 doesn't go into 24. Okay? Alright, so that gives us a decimal value. 24 divided by 5 gives us 4.8. So there we go. X is equal to 4.8. That makes more logical sense, right? And that's inches. You know what? remember when I had 0.048? Okay, guys, before, because I foolishly canceled zeros here when I wasn't supposed to yet. Too early. When I divided it and I went 0.048, I already logically in my mind was going, wow, okay, that doesn't seem right? So that's why mental math is very good, because if you have kind of a rough idea what the number should, or your final answer is, and if you end up with a ridiculous value like I did here, I was already questioning what I was doing. Without even saying it, in my mind, I'm like, oh my goodness, this doesn't seem right. Okay? So this is wrong. You can see we still had the 48, but because I canceled these zeros, I ended up moving the decimal. And that was actually 2 jumps. 1 0 gone, another 0 gone. That's 2 jumps, which makes sense. Okay, this makes more sense. We have a number greater than 1, so 4.8. It looks good now. And that's the answer, guys and gals. That is the answer. Number 3. Yeah, 4.8 inches. Let's go. Yay! All right. That is it. We are going to do some more. I'll do another one today, guys and gals. We're going to continue with some more, I guess, let me give you a couple of problems here. So I'm going to clean up here. I'm going to try to do this quickly. Okay, I'm going to leave you guys and gals with some, I have to actually erase, great. 100. Just give me a sec. I wanted to write out a couple of problems so you guys can kind of work on, and then we'll do them next video. Give you guys some work to practice with, okay? Oh, yeah, definitely do that. Okay, 32, take my eraser off. Okay, here we go. So I'm going to split this into 2 problems. And we have a triangle here. And we have a triangle here. Okay, and they have a check mark here, and they have a check mark here, and they have this here, and they have this here, and they have X here, and they have, I'm not gonna write it, but we have 15 here, and we have 25 here, and we have 20 here. Okay, solve for X. Okay, and then here's another one. So I'm gonna just go like this, just doing it quickly. There we go, good. And then I'm gonna go like this, and I'm gonna go like this, and I'm gonna go like this. That means that's the same angle. Okay, we have X here, and we have, okay, the units are meters, and we have 8 here, we have 25 here, and we have 10 here.
Okay. There we go. And same thing. Solve for x. Okay. And then guys, gals, it's up to you if you want to use it, but there you go. Use the y over x concept. And just practice your ratio proportion and cross multiplying. And also, don't do this, okay? Don't do this. Wait till you get it into fraction form, okay? It has to be in fraction form before you can start canceling zeros, okay? That's my little extra tip, okay? To kind of correct my little mistake. All right? And I'm kind of glad that they happen because then you guys get to see. All right? That is it, Johnny with Whiskey Tango Sharp, Coding and Mathematics. Appreciate you watching. Whoever you are, wherever you are, you're awesome sauce. Remember, look in the mirror and go, I am awesome sauceum. That's right. Turn it up. I'll see you guys in the next video. Solve these problems, and then in the next video we'll do them. All right? Let's do it. Let's do it. You can do it. All right. Drop it. Let's drop it. Okay, check you guys out in the next video. Take care for now. Peace.